Myself, Dr. Basir-Ahamed-Khan, Department of Physics, Krishnath College. This is the lecture 1 of module 8 on Introduction to Thermodynamics. Actually, thermodynamics is the concern with the transformation of heat into mechanical work and vice versa. Before going to introduction of this thermodynamics subject, I want to say some definition of this topic. Today I mainly discuss what is the thermodynamic system, what do you mean by thermodynamic system, extensive and intensive thermodynamic variables, thermodynamic equilibrium, zeroth law and concept of temperature, and about the state function. Now, what is thermodynamic system? Thermodynamic system. Thermodynamic system. A thermodynamic system refers to a certain portion of universe. I repeat again, a thermodynamic system refers to a certain portion of universe which is selected for investigation or experiments. That is, thermodynamic system is a portion of universe which is selected for investigation or experiments. It is imagined to be distinct or set apart from everything else. This is the thermodynamic system. Now, the surrounding. What is the surrounding of thermodynamic system? Everything. Surrounding means everything outside the thermodynamic system is known as surrounding. That means everything outside the system, thermodynamic system, is known as surrounding. In engineering or in physics, some thermodynamic systems are like the gaseous system, gas such as air or helium gas, vapor in contact with its liquid, mixture of liquid, magnetic material, thermocouple, electric cell, etc. and etc. These are all the example of thermodynamic system. That is, thermodynamic system refers to a certain portion of universe which is selected for investigation or experiments. Now, boundary. 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 The boundary of a system is the envelope that encloses the system and thereby separate it from its surrounding. The boundary of a system is the envelope that encloses the system and thereby separate it from its surrounding. That means this is a thermodynamic system. Suppose this is a gaseous system and this wall is boundary. That means boundary of a system is the envelope that encloses the system and thereby separate it from its surroundings. This is called boundary. Now, there are many kinds of boundary wall. With first one is isolating boundary. isolating boundary. Isolating boundary. The boundary that does not allow any exchange of matter and energy between the system and its surrounding is called isolated boundary. Isolated boundary that does not allow any exchange of matter and energy between the system and its surrounding is known as isolating boundary. That means suppose this is a thermodynamic system, this is a thermodynamic system, this is the boundary, and if there is no exchange of matter or energy between the system and the surrounding, then this boundary is known as isolating boundary. And isolated system sorry isolated system, a system which is bounded by isolating boundary, then the system is called isolated system. That means a system bounded by an isolating boundary is an isolated system. 5 is the open system. Open system. Open system, if the boundary of the system permits exchange matter and energy between the system and the surrounding, then the system is said to be an open system. That means if a thermodynamic system, this is an thermodynamic system, this is an thermodynamic system, and the wall is such that, sorry, what happened? Okay. Open system, now if the boundary of the system permits exchange of matter and energy, exchange of matter and energy between the system and the surrounding, this is system, thermodynamic system, and this is thermodynamic system, and this is surrounding. If the boundary is such that the exchange of matter and the energy between the system and its surrounding occurs, then the system is called open system. Then this system is called open system. Exchange of energy and mass, exchange of energy, exchange of energy and mass, energy and mass, exchange of energy and mass, then the system is known as open system. Closed system, this is 4 5, this is 6. Closed system, closed system, if the boundary of a system permits exchange of energy only, that means a thermodynamic system, thermodynamic system, and this is surrounding, this is surrounding, this is, sorry, thermodynamic system, and this is surrounding. If the of only exchange only energy energy exchange, only energy exchange, not mass, between the system, thermodynamic system and the surrounding, then the boundary is called, then the system is called closed system. I repeat again, if the boundary of the system permits exchange of energy only and no matter, the system is said to be closed system. Then this system is close to is known or is called the closed system. That means open system, if I differentiate these two, open system and closed system, open system and closed system, closed system, open system and closed system. Open system, in open system, energy and mass, energy and mass both exchange between, exchange is possible, is allowed, is allowed between system and surrounding, between system and surrounding, between system and surrounding. Surrounding. But in closed system, only energy, only energy is allowed, only allowed to exchange, between, to exchange between, only energy is allowed to exchange between source, say thermodynamic system and the surrounding. This is the main difference between open system and closed system. Closed system, only energy is allowed to exchange between system, thermodynamic system and the surrounding. But open system means the system, the boundary wall is such that, the boundary is such that both energy and mass are exchange allowed between system and the surrounding. This is open system. Now adiabatic wall, adiabatic, adiabatic, a boundary which prevents thermal interaction is known as adiabatic, and the system is said to be thermally isolated. Adiabatic means a boundary which prevents, a boundary which prevents a boundary which prevents thermal interaction is known as thermal interaction. A boundary which prevents thermal interaction is known as adiabatic. Is known as adiabatic. Is known as adiabatic. And the system is said to be thermally isolated. And the system is said to be is said to be thermally isolated. This is adiabatic. And diathermic. Next one is diathermic. If the exchange of heat occurs through a boundary, it is called diathermic. If the exchange of heat occurs through a boundary, if the exchange of heat occurs through a boundary, it is called diathermic. It is called diathermic. Obviously, a system with diathermic boundary will be in thermal contact with its surrounding, and this is very obvious. Now, the thermodynamic variable. Its classification. Thermodynamic variable. Now is thermodynamic variable. Thermodynamic variable. When the condition that any system is in thermodynamic equilibrium, I will say what is thermodynamic equilibrium. The system when the system is in thermodynamic equilibrium, in this condition there will be no change in the system and the surrounding. When the system is in thermodynamic equilibrium, I will say what is thermodynamic equilibrium. Thermodynamic equilibrium, in very short, I can say thermodynamic system is in thermodynamic equilibrium means when three conditions are satisfied. That is, this system is in mechanical equilibrium, chemical equilibrium, and thermal equilibrium. Then the system is called thermodynamic equilibrium. Under this condition, that means in the thermodynamic equilibrium condition, there will be no exchange in the system and the surrounding, and we can say that there is no time dependency of the function of the time in the parameters that can be used to describe a system. Suppose I want to describe a thermodynamic system. Obviously, the thermodynamic equilibrium system a system which is thermodynamically equilibrium, and I want to specify uh, and or to describe this system, we have to need some parameters, and these parameters, since there is no exchange between system and the surrounding, hence the specified parameter are not time dependent parameter. Therefore, the states of thermodynamic equilibrium can be described in terms of these coordinates that do not involve time, and these are known as thermodynamic coordinates or thermodynamic variable. I repeat again, what is thermodynamic variable? Suppose I want to describe a thermodynamic system, obviously a system which is thermodynamic equilibrium are in thermodynamic equilibrium condition, and then to specify this system we need some parameters, but we know that in thermodynamic equilibrium condition there is no change between the system and the surrounding. Therefore, we can say that the variable which I need to describe the system are time independent parameters. Therefore, we say that the microscopic coordinates that do not involve in time, and one character is that they do not involve in time, and these are known as thermodynamic coordinates and thermodynamic variables. Now, in our syllabus or in our limit, we mainly we describe the gaseous system or any liquid thermodynamic system. So we need mainly three parameters. One is pressure, one is temperature, and other is volume. These are the main three thermodynamics. These are the parameters to describe a system, thermodynamic system. So the next thing is that these thermodynamic variables are mainly two types. One is mass dependent and others are mass independent. That means thermodynamic variable are two kinds. This is pressure, temperature, volume. These are the thermodynamic variable which are time independent. There is no time dependency on pressure, temperature or volume, because we describe a system which are in thermodynamic equilibrium condition. Therefore, pressure, temperature, volume, these variables are time independent. But these there are divided, these thermodynamic variables are divided into two types. One is mass dependent and other is mass independent. Thermodynamic variables classified as mass dependent, mass dependent, and other is mass independent. Other is mass independent. Actually, I want to say what is extensive variable and what is intensive variable. The mass independent parameters, the intensive variables are independent of mass. intensive variables are independent of mass. This is intensive variable. This is intensive variable. Intensive variable. Intensive variable. Intensive variable, and this is mass dependent variable or extensive variable. Extensive variable. Extensive variable. So what is extensive variable and what is intensive variable? With the basis of mass dependency, we classified the thermodynamic variables into two types. I repeat again, now with the basis of mass dependency, we classify the thermodynamic variable into two types. One is intensive variable and other is extensive variable. The intensive variable are independent of mass. Intensive variable are independent of mass and extensive variable are dependent on mass. Now here we try to understand the variable with an example. Suppose a system thermodynamic system, this is a 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 thermodynamic system, is in thermodynamically equilibrium condition, is in thermodynamic equilibrium, thermodynamic equilibrium, thermodynamic equilibrium. That means I consider a system which is thermodynamically equilibrium divided into two equal parts, that means here and here divided into two equal parts, divided into two equal parts. Divided into two equal parts, each with equal mass, each with equal mass, each with equal mass, each with equal mass, each with equal mass. The two separate equally divided parts are in same mass, that means each with equal mass. Therefore we can say that if a gaseous system or any thermodynamic equilibrium system is just divided into two equal parts, then we can say that the pressure and temperature will be the same. The pressure and temperature, here is pressure and temperature, this is the same pressure and temperature. But one thing is different. What is these things? This is volume. This is volume. Here volume, if the volume here is V, then here volume is V by 2, here volume is V by 2. volume is V by 2. So we can, with this example, we can say that pressure and temperature are independent of mass, and that's why pressure and temperature are intensive thermodynamic variable, whereas the volume, which is mass dependent, therefore mass is an extensive volume is an extensive variable. I hope it is clear. Thermodynamic variables are classified into two types according to their mass dependency. Now, which are mass independent, these thermodynamic variables are known as intensive variable, and which are mass dependent, these thermodynamic variables are known as extensive variable. With this example, we understand what is mass, what kind of thermodynamic variable are mass dependent and what are mass independent. Now, extensive, now zero thermodynamic equilibrium. Now I want thermodynamic equilibrium. I want to discuss thermodynamic equilibrium. Thermodynamic equilibrium. Thermodynamic equilibrium. Thermodynamic equilibrium. A system is said to be thermodynamic equilibrium which satisfy the mechanical equilibrium, chemical equilibrium and thermal equilibrium simultaneously. Then the thermodynamic system is called thermodynamic equilibrium. That means a system is said to be in thermodynamic equilibrium when it satisfies. That means a system is in thermodynamical equilibrium. A system is said to be thermodynamic equilibrium. Thermodynamic equilibrium when it satisfies mechanical equilibrium, mechanical equilibrium. Second one, chemical equilibrium. And thermal equilibrium. Then this system is called thermodynamic equilibrium. Then this system is in thermodynamic equilibrium. That means it satisfied mechanical equilibrium, chemical equilibrium and thermal equilibrium simultaneously. simultaneously, then the thermodynamic system is known, we can say this thermodynamic system is in thermodynamic equilibrium. Now what is mechanical equilibrium? What is mechanical equilibrium? Mechanical equilibrium, mechanical equilibrium, mechanical equilibrium, equilibrium, mechanical equilibrium. What is mechanical equilibrium? Now for a system to be in mechanical equilibrium, there should be no movement. There should be no movement within the system or of the system with respect to surrounding. Then the system is in mechanical equilibrium. That means there is no movement. No movement. There is no movement. There is no movement in between is within the system or of the system with respect to surrounding. Then this is mechanical equilibrium. What is chemical equilibrium? Chemical equilibrium. Chemical equilibrium. What is chemical equilibrium? That means there should be no chemical reaction within the system. No chemical reaction within the system. No chemical reaction. No chemical reaction. Chemical reaction within the system. No chemical reaction within the system. Within the system. Then the system is known as chemical equilibrium. Thermal equilibrium. Thermal equilibrium. Thermal equilibrium. Thermal equilibrium, that is, for a system to be in thermal equilibrium, there should be no temperature difference between the parts of the system or between the system and the surrounding. That is, no temperature difference. No temperature. No temperature. No temperature. No temperature difference. No temperature difference. No temperature difference within between the parts of the system. Between the parts of the system. Between different parts of the system. Different parts of the system. Different parts of the system. Then this is thermal equilibrium. Then thermal equilibrium. So when these three equilibrium conditions satisfied simultaneously, then we said that the thermodynamic system is in thermodynamic equilibrium. Now the second topic is zeroth law of thermodynamics. 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 What is zeroth law of thermodynamics. The zeroth law of thermodynamics states that when two system, zeroth law of thermodynamics states that if two systems A and B, if two systems A and B, if two systems A and B, two systems A and B are each separately in thermal equilibrium with a third system. Separately is in another system C, then A and B are also in thermal equilibrium with each other. I repeat again, the zeroth law of thermodynamics states that if two systems A and B are each separately in thermal equilibrium with a third system C, that is thermal equilibrium with separately thermal equilibrium between A and C, thermal equilibrium between A and C. If there is a thermal equilibrium between A and C and C and B separately, if A and B are each separately in thermal equilibrium with C, then A and B are also in thermal equilibrium with each other. Then A and B are also in thermal equilibrium with each other. That means then A and B are in thermal equilibrium. This is the zeroth law of thermodynamics. I repeat again, zeroth law of thermodynamics states that if two systems A and B are each separately in thermal equilibrium with a third system C, that means A and B separately thermal equilibrium with C, A with C, thermal equilibrium with C, and B in thermal equilibrium with C. First one A with C and second one C with B. Then A with C, that means A system with B C system. Separately B system with thermal equilibrium with C system. Then A and B are also in thermal equilibrium. Then A and B also in thermal equilibrium. So A separately thermal equilibrium with C, B system separately thermal equilibrium with C. Then A and B are also in thermal equilibrium with each other. This is the zeroth law of thermodynamics, and this law gives very important conclusion or the concept of very important thing, which is temperature. Since these thermodynamic systems are in thermal equilibrium, then we can say that one parameter must be same between these two systems. The parameter is called temperature. That means this law gives the concept of temperature. This law gives the concept of temperature. This law gives the concept of temperature. This law gives concept of temperature. Concept of temperature. That means temperature of these different system will be the same, otherwise these systems are not in thermal equilibrium. That means zeroth law of thermodynamics gives the concept of temperature. Now state function. Equation of state. Equation of state. Equation of state is a mathematical function. Equation of state. Equation of state. This is the next topic. Equation of state. Equation of state is a mathematical function relating the appropriate thermodynamic coordinates of a system in equilibrium. That means equation of state is a mathematical function. Equation of state is a mathematical function. Mathematical relation or function relating the appropriate function relating is a mathematical function relating the appropriate thermodynamic thermodynamic coordinates of a system. Thermodynamic coordinates of a system in equilibrium. Every thermodynamic system has its own equation of state. Suppose, for example, a system consisting of a gas at very low pressure has the equation of state of an ideal gas. The equation of state ideal gas, where the pressure is very low, the real gas behaves like an ideal gas, and the equation of state is PV, pressure into volume, equal to nRT. R is a universal constant, N is the number of moles, and T is the temperature of the system. And for real gas, this equation of state, real gas, this is 1, and for real gas, equation of state, real gas equation of state P plus A by V square, P plus A by V square, V minus B equal to nRT. nRT, where A and B are constant, A, B are, these are constant. So this is the example of equation of state.